Hey guys, we're on Unit 11. This is day 6, and we're going to talk about tangents today. Okay. In the warm-up, it says in the accompanied diagram, a circle OPBA and PCD are secants. Chords AC and BD intersect. And the measure of angle ABD, so A to B to D, this angle here is 55 degrees. And then they also tell us that the measure of arc AB is equal to the measure of arc DC. And so like line segments, we tick mark them to show that they're equal. And the measure of arc BC is 50 degrees. So from B to C, this arc here is 50 degrees. They want us to find the following. So the first angle up, they want us to find the measure of angle ACD. So from A to C to D, that's an inscribed angle. And that inscribed angle actually eats the same arc, okay, or intercepts the same arc as this other 50-degree inscribed angle. So we're going to use this 55-degree angle as our inscribed angle. Inscribed angles are equal to half their arc. So our arc here has to be 110 degrees. So that half of 110 is the inscribed angle of 55. We're also going to use this 110 arc to get this inscribed angle to be half the arc, which is 55 degrees. Okay, so two inscribed angles that have the same arc are equal. Okay, and so this angle is 55 degrees. Okay. Angle P. Angle P is an exterior angle, and exterior angles are equal to their arc minus their arc divided by 2. And so if we want to find that angle, we have to know the inner arc, which is 50, and we have to know the outer arc, which if we follow the sides of the angle out, is the 110. All right, and 110 minus 50 is 60, and 60 divided by 2 makes our exterior angle 30 degrees. Okay. Part C, angle DBC, D to B to C. That is also an inscribed angle, but we're missing the arc. However, if you guys remember from what they gave us, these two arcs here that are equal, and they're the only two arcs missing from our circle. So we're going to take 360 degrees. We're going to subtract the two arcs that we have, which are 110 and 50. And that is going to give us 200 degrees left to split equally between those two arcs that they told us were equal. And so that makes those two arcs 100 degrees each. So 100 degrees up here and 100 degrees down here. And now we can look at this inscribed angle here that we have in yellow. That eats the 100, and so that angle has to be 50 degrees. Okay. We have next is the measure of angle AED. A to E to D. This angle here is what they call an interior angle. And interior angles are equal to arc plus arc divided by 2. And so this interior angle here, okay, one of the arcs is 110. And remember that vertical angles are equal, so this angle would be equal to it, and this angle would eat the arc of 50. So the other arc is 50. So we're going to add them together this time. So 110 plus 50 is 160. Divided by 2 is going to give us that angle of 80 degrees. So this comes out to be 80. Okay. And then the last angle they're asking about is angle PCB. So P to C to B. That angle is formed by a secant and a chord. And so we don't have a rule for that one, but what we do have, and it's hard to see here, but we have 3 angles all lying on a line next to each other right here. Okay? All 3 of them will add up to equal 180 degrees. And we have one here that's 55 degrees. Okay? This one here in the middle is an inscribed angle. It's also the last angle of our triangle. So we could find it either with triangle sum, seeing that this triangle here has an 80 and a 50 in it. This angle has to be 50. which makes sense because it's an inscribed angle. It's half the 100-degree arc that it would eat. And so we're going to now take 180 degrees and take away the 55 and take away the 50. And the last angle on the line here has to be what's left over, which is 75 degrees. All right, so tough picture, a lot going on. Okay. Let's take a look at what we have today. This is something we've actually already talked about, but when you have a tangent like PR and you have a radius like OR, they're perpendicular at their point of intersection, okay? So a tangent and a radius, when they meet, they're perpendicular. They make a 90-degree angle, okay? And how that's going to help us is if that right angle is in a right triangle, like in this next picture, number 1. It says a PO here is 10. Okay. RO is 6. They want you to find PR. Well, that's just the third side of a triangle when you know the other two. And so we're going to go ahead and use a squared plus b squared equals c squared. We're going to take a out and replace it with 6 squared plus b squared equals, the 10 has to go in for c because the 10 is representing the hypotenuse because it's the side across from the right angle. Okay. This will be 36. This will be 100. And if we subtract 36, we're going to be left with b squared equals 64. When we take the square root, b comes out to equal 8. And now we can go ahead and say that our PR or RP is equal to 8. Okay. Let's see what else we have. Next one up says 2 tangent segments drawn to a circle from the same external point are congruent at the point of tangency. So right here we have a tangent called BA, and here we have a tangent called BC. And what they're saying is that this line segment here, BA, is going to be the same length as this line segment BC. Because they're both tangents, they're going to be congruent line segments. Okay? I always think of this kind of being like an ice cream cone. So hopefully you guys can see the ice cream cone here. We can make it look more like an ice cream cone. So the sides of the ice cream cone are the tangents, okay? And then the circle ends up being the ice cream. So I always think that if the sides of your cone, right, the sides of your ice cream cone are equal, your ice cream's going to fall on the floor, all right? So that's an easy one, hopefully, for you guys to remember. So in number 2, this might be how they ask a question about it. They want you to find perimeter of triangle ABC. We know perimeter is the sum of all the sides of the triangle. Problem is we don't have all the sides of the triangle. We got some gaps in here, all right? We know that this side here on the bottom is 10, so that's one of our sides, but we're missing the length of this side, and we're missing the length of this side, all right? However, based on what they said up there, if you guys can see CF and CE are 2 tangents there to the circle, okay? And one side is 3, the other side has to be 3, okay? Those 2 segments have to be equal. And so by doing that, now we can have the full side here, 6 and 3, part plus part equals the whole, which is 9, okay? On the other side here, EB and DB, you guys can see how those are 2 tangents, okay? And so this has to be 7, all right? Going up to the top of our picture here, okay, we also have 2 tangents here, AF and AD, and therefore AD must be 6. And now we have the full side there of our triangle, part plus part, 6 plus 7 is 13. Okay? And now we can go ahead and find the perimeter of triangle ABC. One side is 9, one side is 10, one side is 13, and if we add them up, our perimeter comes out to equal 32. Okay? All right, guys, I'll see you on the back side of notes.